Problem number 33. Find the values of a, b, and c, which make f of x, y, z is equal to sine of x to the a times y to the b times z to the c. A potential function for the vector field f. It's a long expression there here. I'm just going to observe that, like, if you see in each of those there's cosine of x cubed y to the 6z cubed. So let's just try this as sine of x cubed y to the 6z cubed. So what happens when we take the gradient of f, gradient here of little f, we end up with, let's see here, the x partial derivative is 3x squared y to the 6z cubed times cosine of x cubed y to the 6z cubed. The y partial derivative will be 6x cubed y to the 5th z cubed times cosine of x cubed y to the 6th z cubed. And the z partial derivative is going to be, let's see, 3x cubed y to the 6z squared times cosine, once again, of x cubed y to the 6z cubed, which is exactly the vector field f that we were asked about in this problem. So here are the choices of a, b, and c in part A. For part B, find the work of f along the curve. R of t is 2t, e to the t times t minus 1, e to the t times t minus 1, and t runs from 0 to 1. So we're looking for the integral along this curve C here of f dot dr for this vector field f. And so we should know by fundamental theorem for line integrals, because our vector field f has a potential function, we can just evaluate this by evaluating the potential functions at the endpoints here and subtracting. So all we have to do is determine the endpoints here and plug into our potential function, subtract, and we're done. So what are the endpoints here? A comes from t is equal to 0. And so plug t is equal to 0 into r of t, and you get 0. And e to the 0 is 1 times 0 minus 1 is negative 1. Negative 1. So there's that starting point. The ending point is corresponds to t is equal to 1. This would be 2 times 1 is 2. And then these two terms both have t minus 1s in them. So they end up at 0. So f of b minus f of a is, okay, f of b, we need to plug in things into here. Sine of 2 cubed times 0 to the 6 times 0 cubed. And then we plug in, okay, an f of a here, plug in 0 cubed times negative 1 to the 6 times negative 1 cubed. And realize here, these are both going to be sine of 0. And so we end up with sine of 0 minus sine 0 is 0. So realize just how nice using the potential function made our lives. This would be an extremely intimidating integral to compute if we had to take the derivative of r of t, plug in r of t into this vector field f, take a dot product of that with the derivative, integrate, and this becomes a breeze to evaluate.